Okay, 14F, Newton's law of motion, friction, example 28. So example 28 says an object of mass 5 kilos at rest on a rough horizontal plane is pushed by a horizontal force of 20 newtons for 5 seconds. The frictional force on the object when it is moving is 16 newtons. How far does the object travel during the first 5 seconds? How much further will it move after the pushing force is removed? So let's set this up. We're on a rough plane, horizontal plane. We have 20 newtons going in our positive direction. We're calling this our positive. We've set up our I horizontal, J vertical. Vertically, you've got your weight of 5G going down and your reaction force going up. They'll be equal. And our friction force when it's moving is 16 newtons. The mass itself is 5 kilos. Now we know that the resultant force is going to be 20 in the I direction, take 16 in the I direction. The 20 that way and the 16 that way. So our mass times acceleration is equal to -4I. Our mass is 5, so our acceleration is -4/5 I direction. Now we're working only in the one direction, so I'm going to not write I from now on because we know in that I direction is what we're dealing with. Now we have A is equal to 0.8. And we need to know how far does the object travel during that first 5 seconds. So we know A is dv dt, is 0.8. So dv equals 0.8 dt, or dt I should say, I wrote that the wrong way. So V equals 0.8t plus c. Now if we say initially t is 0, V is 0, x is 0, t is 0, v is 0, therefore c must be 0. So v equals 0.8t. We happy with that? So at t equals 5 seconds, v equals 0.8 times 5, v equals 4 meters per second. So that's after 5 seconds. We're also talked about how far does the object move during those first 5 seconds. Now, from this down, dx dt equals 0.8t. dx equals 0.8t dt. Integrate both. X equals, there'll be 0.8t squared on 2 plus c. Go back up here. So x is going to equal 0.4t squared plus c. Now if we say when t equals 0, x equals 0, that's what I wanted to write before, just use it now. T equals 0, x equals 0, so therefore c equals 0. So x equals 0.4t squared. So at t equals 5, x equals 0.4 times 5 squared, 10 meters. So in that first 5 seconds, at the end of the 5 seconds, the speed is 4 meters per second and it has travelled 10 meters. Now after that 5 seconds, for part B, how much further will it move after the pushing force is removed? So now we're doing that our force is just equal to -16. That's 5a equals -16. A equals -16 on 5. A equals -3.2 meters per second squared. So we've only got that friction force, if you will, want to call it that, acting. Now, we need to work on from that. We want to know how much further it's going to go. We don't know time. Go. This time, how much further? Because I want a distance. I'm going to split my acceleration is v dv dx. Okay, so v dv equals negative 3.2 dx. Integrate both. A half v squared equals negative 3.2 x plus c. Now at the end of that 5 seconds, we knew that v equaled 4 and x equaled 10. So if I go a half 4 squared equals negative 3.2 times 10 plus c, that's 8 equals negative 32 plus c, c equals 40. Sorry about that, that was a bit wonky for the video. So now we've got, it's a half v squared equals negative 3.2x plus 40. How much further is our object going to travel? We want to travel till v equals 0, and we want to work out what x is. So that's a half 0 squared equals negative 3.2x plus 40. This is going to go to 0, obviously. So I've got 3.2x equals 40. X equals 40 divided by 3.2, which gives us 12.5 metres. So after 12.5 metres, the object stops. Now remember though, originally it had travelled 10 metres in the first 5 seconds, 10 metres in 5 seconds. So it's travelled a further 2.5 metres. Just remember it's the same in that previous example. The question says how much further will it travel? So it's after it's already travelled 10, so 2.5. That's done.